Hi there! Let's simplify rational expressions. And what is an irrational expression? First of all, well, rational expressions are expressions like these, which are ratios of two polynomials, one in the denominator and one in the numerator. And they're polynomials because they don't have radical signs or square root signs or any fractions. It's just the variables and their counterparts. So anything that looks like a polynomial can be x squared plus bx plus c, or x minus 1, anything that's typically in a quadratic, cubic, linear function. If it's not a function, it normally isn't a polynomial. And oftentimes we can simplify these by factoring or taking out a common GCF. So let's try them out. So for this one, we need to find common denominators or numerators or just numbers that each one shares. So let's start off with the top one. X squared plus 5x plus 6. Well, that looks like a factorable quadratic. So let's think about it. What adds up to 5 and multiplies to 6? Well, there's only a few options, but it can be 2 and 3. So x plus 2 and x plus 3. For the denominator, we can't really factor, but we can take out a common greatest factor. So for here, it would be x. We can take out x and leave x plus 3. And immediately you can see that the numerator and denominator do have something in common, which is x plus 3, so we can just cancel them out. And we simplify to get x plus 2 over x. Now wait a second, we're done here. But don't go further and say, oh, I can cancel off the x's. Actually, you cannot, because it's crucial you do not, because the top numerator, x plus 2, it's like a package. You can't take half the package. You have to take all of it or none of it. So if you see an x plus 2, you cannot just take away the x and leave the 2. You have to make it stay there, or take the whole thing. Let's try to simplify this one. So for the numerator, we see that they all share x, so let's immediately take that out. X squared minus 2x plus 1. And for the denominator, it's actually a difference of sums, a difference of squares. So for here, it would be x plus 1 and x minus 1. Don't forget that it's crucial to memorize your properties of different kind of functions here, expressions. So we can still further reduce this. The top part can still be factored, so let's factor that to x minus 1 squared, and the bottom is x plus 1, x minus 1. So we can just get rid of the squared sign here, leaving just 1, and our final answer is x minus 1 over x plus 1. So let's try one more problem here. Let's simplify the top part, the numerator, so we can take out the 4, leaving x minus 3. And the bottom part, well, what multiplies to negative 21 adds up to 4. That would be positive 7 and negative 3. X plus 7, x minus 3. Let's cancel them out, and we're left with 4x plus 7. Let's try one more. So this is the last one, I promise. And generally, though, most expressions don't go further than cubic roots, cubic functions, because those get too hard to easily factor, and most of these are pretty simple. So let's try this last one. So the top part, we would remove the common factor x, so x squared plus 7x squared, 7x, plus 20 over, and let's factor this. It would be x plus 5, x minus 4. We can still factor the top part, which would be x plus 10, and let's change this to a 10. Alright, so it'd be x plus 2 and x plus 5. And bottom is still the same. So let's reduce these two, and we're left with a final answer of x plus 2 over x minus 4. So thank you for watching. This has been Simplifying Rational Expressions by SATFreePractice.com.